the 6th lecture on matrices, and it's just building up a bit more on the Gaussian elimination and just basically definitions. Right, this first definition is echelon form. Now, echelon form is where you have a complete line of zeros on the bottom when doing the Gaussian, or if there's a zero to the right of the leading coefficient on the line above. So because we got a 0 here, and there's a 9 here, and the 0's in front of it, this is also echelon form. Now this one below here is not, because there is a leading coefficient is below it, and it's, well, not to the right. Now you can have a value here, but if there is a value here and this 0 is leading, then this means that there is no solution to the Gaussian method. So there's no answer to the x, y and z. Another thing, which I have a bit more on the next slide, is the rank. Now, if you have zeros here, or like here, then everything above, so above here, the rank of this is 2, because you have zeros and zeros. If they're all zeros, then everything above is the rank. So we have 1, 2 left above, so this is the rank of 2. So generally they do this by saying d1 dr. So you have d1 dot 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 dr, and then this will be known as dr plus 1 down to dm, because it's the number of rows, m by n matrix. Now for this one, we have 0, 0, 0, there 3, so the rank is anything above, so we have 1, 2, the rank is also 2. This one, we have, well, there's no 0, so the rank of this is 3. So it's 1, 2, 3, so the rank is 3. And there's just a little bit more. Now, we refer to the rank as r in this. Now r is always less than or equal to m. Now that's obvious because m is the number of rows, and since we're counting the number of rows for the rank, then it has to be. And this is the same for the number of columns as well. So the number of columns, it's going to be less than or equal to the number of columns, which is just plain logic. And another thing, if r is equal to the number of rows, m, then there is always a solution. And this is similar to our Gaussian elimination we did in the last lecture, because r was equal to m all the time and there was a solution. If r is equal to n is in the number of columns, then the solution is unique and there is only one solution. And that was basically it. You can check with the previous examples in the last lecture, which if you're on the web page is up there, and just check the rank. Now this is all it pretty was.